So your homework last night was page 27. Um, oh my gosh, words. Did we go over page 26 in this class? Like, I don't remember. Did I give you the answer?
Yeah.
Okay. So I know for some of my classes, I did not get a chance to do that. So in case they are watching the video, you can go ahead and check this. You can pause it if you need me to go slower and let me know if you have any questions. All right. Now on to last night's homework, which was page 27. First things first, were there any that gave you trouble after we went over number 4? Because I know you didn't know number 4 right away. Yeah, 24, 13, and 24. Okay, so let's start with 24. Sedimentary rocks form at or near the blank of Earth. So that was right from these notes that we did yesterday. To the bottom here. They form in horizontal layers at or near Earth's surface. And why? Because that's where all the weathering, erosion, and biological activity takes place. So just to give you a quick explanation, sedimentary rocks come from sediments. How do we get sediments? They're broken rocks. And how do we break rocks? Weathering and erosion. Maybe you guys don't know this yet, but weathering and erosion choices are running water. So, like rivers can break rocks, wind can break rocks. If it's windy enough, the rocks can move around and bump into things. Waves can move rocks and break them. Glaciers can move and break rocks, and so can gravity, can just break rocks. So, all of those things are all on the surface. Animals can also break rocks, like worms and things like that. They burrow through and break up the rocks in the dirt. All of that stuff happens on the earth or the surface of the earth. So that's where that one was. Now 13, right? That's the evaporation of seawater one. If so I had showed that quick video about the crystalline rocks, the chemical ones. These are crystals from chemical precipitates and evaporites. And long story short, an evaporite is when the ocean evaporates or the salty water evaporates and leaves behind the minerals that were in it, like the rock salt or the gypsum. And precipitates are what happens in caves. These three are the ones that come from evaporation of seawater. So it's just the evaporites and precipitates. So rock salt, rock gypsum, and dolostone. Were there any others that just gave you a hard time? Couldn't find them on the reference table. So the rest of them, you're pretty sure the first part of 12. Sandstone is made up of blank size particles with a grain size of. So what I was going for there's sandstone. It's made of sand size particles that have a grain size of 0.006 to 0.2. So I just wanted to make sure you realize that in that case, sand is the sediment. That's like the name of it. And the grain size is 0.006 to 0.2 centimeters. Make sense? I think they would probably say the sediment size if it was the region so that it was clear. Were there any others that you just weren't sure, or did we ace the rest of it, you think? Okay, just to give you the answers, then we've got. So number 1 should have been limestone and bituminous coal. 2 is composition. 3 is limestone because it's okay, so 3 is limestone. 4 is also limestone because it's made out of calcite. 5 is coal, 6 rock salt, 7 carbon, 8 grain size, 9 breccia, 10 siltstone. 11 is less than 0.0004. I caution you as to using the less than or greater than or those symbols. You know what I'm talking about? The little half triangle things. You can use them, but you have to make sure you use them correct. And I think that's more thinking than most of us like to do. Yeah, whatever. If you can remember it, good. I'm not teaching it. So It's one of those things where if you are positive you're good at using them, you're more than welcome to. I don't recommend it because it's just one place that you can mess up, and it has nothing to do with earth science that you're messing up. So I like the words less than or greater than better than the symbols. But like I said, if you got them, you have them memorized and you're good with them, more power to you. You're welcome to use them. But it's a lot like doing math in your head. Like you're pretty sure you got it, and then you screw up adding 6 plus 4. Like, don't do that. Where are we? So we got 0.006 to 0.2, or sand, and 0.006 to 0.2 rock salt, rock gypsum, dolostone, limestone, and bituminous coal. 15 is slate. 16 conglomerate, 17 limestone, 18 sandstone, 19 gypsum, rock gypsum. 20 is dolostone, 21 bioclastic, 22 inorganic, 23 crystalline, 24 they're found on the surface because that's where all the weathering, erosion, and biological activity happen. The first question, 25, is sedimentary. The second 25 here is that those basically explain that the formation of the other rock types would destroy a fossil. Or you could say because sedimentary rocks are exclusively formed on the surface. Either one. And then finally 26, straight off of the rock cycle. They happen when sediments get deposited, buried, compacted, and cemented together. I used deposition, burial, compaction, and sedimentation of sediments. Any others that you got wrong on there? It's all from the reference table or our notes. So if it wasn't a 3-day weekend, I was going to assign 28 and 29 for homework, but I decided that we all need a break, so no homework on that. If you're a person who likes to get ahead on a weekend because you don't want work during the week, they will be homework next week. So if you want to do 28 and 29 because it's the weekend and you have more time, go for it. It'll save you some work over the week. There's 2 people. There's lots of people saying no way, and a few people who are writing that down. So I don't know which, no judgment either way. Before we get started, I got your mineral quizzes from the other day. I had somebody else grade these for me, which was lovely, but I want to make sure that no mistakes were made. So we are going to go over them real quick. Make sure that there was no grading mistakes. Okay, so first thing, this is your first grade of the second quarter. Your homework that I just checked is also going on the second quarter. So if you were in Power School and you noticed your second quarter, you already have a grade, that's what it is. Oh. If you didn't do so good, it's going to make your second quarter look really crummy. But quizzes are worth practically nothing. In fact, homework is worth just about the same as quizzes. So as soon as we get a couple homeworks in there, it will balance out this quiz grade. So if you do not like your second quarter grade, just keep doing your homework and that grade will basically disappear in a couple days. Just need to get some more in the grade book. And I will put these homeworks that I just checked in there to balance out any bad grades that you just don't like to see. Don't stress over quizzes, but use them as your wake-up call that clearly you weren't understanding something if you did bad on a quiz. So make sure that whatever you got wrong on this quiz, you now understand it so that when we take a test, which I'm thinking, by the way, next Friday is going to be the test on this chapter. So make sure you're comfortable with igneous rocks by next Friday. So speaking of, let's go through the answers. We got one is D. If you picked A, you are a statistic. You fell for their trick. Rhyolite answers all of that. Rhyolite is 5% amphibole, 8% biotite, 15% plagioclase, 37% quartz, and 35% potassium feldspar. But you missed the first part of that. It says which igneous rock formed from magma that cooled slowly. Rhyolite is a fine texture. It's extrusive. So extrusive rocks cool quickly. Granite also says all of those things, and it does cool slowly because it's coarse. That was an example of the first answer, letter A, worked pretty good. You fell for their tricks. They're mean old jerk faces. All right, back to going over this. Number 2 is C. 3C, 4B, 5B, 6D, 7A, 8A, 9B, 10D. Take a look at them. Which ones should we go over? Yeah. Yeah, so I'm going to start with 2. So 2, so it's asking you, what does this picture, they tell you that it's a rock that can float in water. They tell you this is a magnifying view of it. What do you was the first thing you notice when you look at that picture? Holes. That's what you were supposed to see. Another name for holes is gas pockets. So gas pockets, those holes are gas pockets, which means this rock is vesicular. Vesicular right there. Could it also be non-crystalline? So non-crystalline just means glassy, and yes, vesicular can be glassy. Clastic and fragmental, that's a sedimentary rock thing. That would tell you there's broken pieces of other rocks. There's not in that one. Now, we did not learn about foliated and banding till today, but I can guarantee you it doesn't look like this. And this one told you it was non-vesicular, and you hopefully saw some holes in there. Did you pick D, though? So the reason I'm thinking you picked D is the word coarse. Did you think the word coarse meant rough? Yes. So that's what we have to stop using our common sense, which I know this is probably the only time a person's going to tell you this is to not use your common sense. But we have to remember that coarse means the crystals are 1 to 10, which are intrusive, and those are big, big crystals. So coarse is talking about the crystal size, not how it feels. And then you said 13. What did you? No, we couldn't say 13 because there isn't one. 9. Which texture best describes an igneous rock that formed deep underground? So deep underground are going to be your intrusive, inside the earth. So intrusive igneous rocks, they're not going to be fine-grained. So process of elimination. Inside ones are going to be coarse or very coarse. So, and they can't be vesicular because that's up here in the extrusive only. So the only thing that's something that's intrusive inside the earth can be out of the 4 choices was coarse. Which one did you pick? A. Okay. It was a comment that was a lot of people got that one wrong. So I think it was maybe just going too quickly or not thinking enough about it. I also think now that you guys have finished the Igneous Rock Lab, I think you guys are doing better on this now. So hopefully by next Friday, it's real good. Are there any more you want to go over? No? Okay, then I really just have one small thing to start, and that's on page 31. Thank you, Jack. Page 31 in your packet, we're going to start the notes from metamorphic rocks. It's the last rock chart we have to do. It's just like all the rest of them. We're going to go through this pretty quick because a whole bunch of the things mean the same thing they meant on the other ones. So hopefully you guys are becoming excellent at reading these. So once again, you can't see mine very well up here. I don't know how they printed on yours, but it is the chart from the bottom of page 7. So you might want to have page 7 of your reference table open and off to the side if you need to refer back to it. So this is another dichotomous key, another version of the Guess Who we played a couple weeks ago. I'm thinking back, so quick review sesh here. What was the first thing we looked at for minerals, according to the reference table? Luster. First question we asked about a mineral is what luster do they have? Metallic or non-metallic? What was the first thing we looked at with igneous rocks? Environment of formation. And to go with that, how did you know if it was extrusive or intrusive? But how did you know by looking at a rock? By the crystal size. So the first thing over here. So igneous rocks are a little weird because you kind of got to look at 2 of them at the same time. What was the first thing I want you looking at for sedimentary rocks? Texture. So whether they were clastic, made of fragments, crystalline, made of crystals, or bioclastic, made of fragments of once living things. Take a look at the metamorphic rock chart. What do you think the first thing we're going to look at in this one's going to be? Texture. So you guys already know how to read the reference table, which is really important. This big bubble right here is supposed to be for pointing to the texture box. Just so you know how big, kind of to gauge how much you have to write. Let me show you last period. Last periods took up that much. So kind of gauge your writing based on that. What are the types of texture listed in these boxes? Foliated and non-foliated. Any idea what the word foliated means? Probably not. But what word do you hear in that? I hear fold. So here's a piece of paper. How many layers are there? 1. When I fold it, what starts to happen? More layers. So I could keep folding this and I'd have lots and lots of layers. That's my reminder of what foliated means. Foliated means layers. Let me see how I wrote this. Minerals are aligned in layers. You can probably just get away with layers. So the vocab or the keyword there is layers. Now looking at that foliated box. Foliated actually gets broken up into 2 different types of foliated. It's still considered their texture. We have banding and mineral alignment. What does banding or bands mean to you? Something like that. Okay, so it's stuck together. Okay, that makes sense. Oh, yeah. I mean, sure. That sounds like living things. We don't want to talk about living things. I hate living things. Not all living things. I hate learning about living things. What about a rubber band? When you put a rubber band on a rock, I now have like a black layer. Check out the layers on this rock. What do you notice about it? Not really straight across. They're not straight across. Do you see the layers, first of all? They're really easy to see, right? Why? What makes this rock so easy to see the layers? Because they're different color. They have bands of color that go around them. That's what banding means. So just like when I put my rubber band on that, I had a band going around the rock. Banding, there's bands of different colors. So to define this officially, Banding is alternating layers of color. Stripes. So the kicker there again is it's still layers, but they're just different colors. Whereas this one, and I know this doesn't show up very well. In fact, I don't. Carly, would you be able to turn the other light off for me? Right. In this case, can you see the bands at all? Oh, you can kind of see the layers. Yep. I think with the light. Oh, off. Well, hopefully you can see them. Do you see different layers here? But they're all the same color. That's called mineral alignment. I'll pass it around. You should be able to see it a little bit better. Oh, spelled a line wrong. Mineral alignment. These are minerals are lined up. Ooh, I'm struggling. And I'm going to put parentheses, same color labels. Not labels, layers. This is why there's no homework. We all need a brain break. Layers means foliated. So what do you think non-foliated means?
Oh, yeah.
No layers. This is really the only like real new stuff that's on the reference table. The rest. Let's wait. Everybody good? Nope, not yet. Okay. So that's, I think, the only new stuff you have to learn for metamorphic rocks. But just to go through the whole reference table, the next, okay, sorry. The next box we're going to look at after texture is grain size. And we've done grain size in igneous rocks. We've done it in sedimentary rocks. It means the same thing here. So grain size is how big the crystals are. So they use some of the same vocab words we've been used to. So fine on metamorphic rocks means the same thing fine means on igneous rocks. So it means the crystals are less than 1 millimeter. Some of the other choices, they have coarse in there. They also have medium. That's not a choice on igneous rocks, but as you can see on the metamorphic rock chart, grain size isn't all that important. What's more important is going to be the composition. Composition, just like the rest of them. What does composition mean? Yep. What the rock is made of. And taking a look at the reference table, the non-foliated rocks are super easy to read. No guessing, no thinking required. So anthracite coal, we go over to the composition, it's made out of carbon. Quartzite, go over to composition, it's made out of quartz. I skipped Hornsfeld, but it's made out of various minerals, so that one's a little weird. Marble is made out of calcite or dolomite, and metaconglomerate is made of various minerals. The top's a little weird. It's different, but not difficult. So I mentioned the other day how much the Regents loves bar graphs. They'll throw a bar graph at you any chance they can get. I'm pretty sure you can figure this out though. So basically, if the bar is there, then that rock has that mineral in it. For example, slate. If you follow slate over, there is only one bar lined up with slate. So that means it's only that one thing in slate. So mica is the only mineral in slate. Take a look at phyllite. What's in phyllite? So there's still mica, so just or mica, however you want to pronounce it. But there is still now, because we got the quartz box up there, feldspar, amphibole, and garnet. So phyllite has everything except for pyroxene. Here's my favorite. This is schist. My very favorite piece of schist. What's up with schist? What's in schist? All the time? No. If you find a piece of schist in your backyard, wouldn't you?
Yeah.
Okay, sometimes it's okay to be slightly immature. If one of the words you have to learn is schist, you got to go with it. I won't slip up. I've been doing this for 17 years.
Have you slipped up?
No. So if you find a piece of schist in your backyard, it might have, well, it will always have mica, quartz, feldspar, amphibole, and garnet, because those boxes are in it all the way. Some pieces of schist have pyroxene. Some pieces of schist don't. But then we get to this one. What's that word? It's not. It's just print. It's not Guinness. It's not genius. It's not Genesis. It's just nice. I did hear one. I didn't know who said it. It's just pronounced nice. Now, come on, guys. Who read my shirt? Wait.
I was gonna say.
I knew. Nobody in my fourth period class laughed at me. And I specifically said, next period, we'll laugh. So I really appreciate you guys laughing at me. Holy schist. That's nice. My nerdiness goes deep, guys. I wear this in public. My kids just shake their head. My husband just doesn't get it. I got my ways. Got my ways. I think this one was from Etsy. I've got more. Don't worry. I'll be rocking out some new t-shirts later. Get it? Rocking out. I'm on a roll. I can't even help myself. Keeping it real, guys. Keeping it real. So you guys understand how to do the composition. Okay, if the bar is there, that rock has it. All right, we're moving on. We got, oh shoot. We put this in the wrong box. Oh shit, what are we gonna do now? Okay, so did you guys label this box composition? Okay, so make sure you realize it's pointing to the composition box. And we're going to take this box and move it over one. So this one that was pointing to the composition is now pointing to the type of metamorphism. Ooh, but we got to write a lot. Well, write a little small. Type of metamorphism. There are two types. The first is regional. What does regional mean to you?
In a specific spot.
But is it a small spot or a big spot?
A big spot.
Big spot. The whole region. So this means high temperature and pressure affect a large area. High temp and pressure affect large area. This happens when mountains are built. So it says regional, high temperature and pressure affect large area. Mountain building is this. How are mountains made? They just like a pimple. They don't build up. What do you got, Riley? Riley, do it. And what do? And they push up. Does that sound familiar now?
And
So-
can't they collide?
They can. So we're doing plate tectonics is our next chapter. So if you don't remember this, good news, I'll teach it to you. But one way mountains are built when two plates collide, well, when they collide, when two continents hit each other, like India hitting Asia, that's building the Himalayan mountains and Mount Everest. So that's when the two continents hit, both continents end up going up and they create a mountain. Yes, you're going to learn that when plates hit, they can do a whole bunch of other things, but that's for next chapter. But what I'm getting at is picture two cars running into each other. There's a lot of pressure in that. Like, think of the damage that happens when just a car hits another car. Imagine what happens when a continent hits another continent. But it is slowly, but it's so slow, but it's all day, every day. It's pushing and pushing and pushing. There's a lot of pressure. Mountains require a lot of pressure. And that pressure will change the rock in the whole rock, in the whole mountain. So that's where regional comes in. The whole region gets pressure versus contact. Sorry, we got to write this small. I got distracted with my funny jokes. Contact metamorphism is molten rock touches other rocks. So remember, metamorphic rocks are formed by heat and or pressure. So let's say that there's lava or magma flowing through the earth, coming from down below and squeezing its way up to the surface, which is, I'm going to be that hot lava. You guys are going to be my existing rocks, okay? So hot lava squeezing its way through and it touches their shoulders. Touches their shoulders. What happens to their shoulders? I'm hot lava. They're rocks.
They melt.
Now, do they melt? Like, think of making a s'more. If you make a s'more and you have your flaming marshmallow because you're my daughter and you have no patience, and you make a flaming marshmallow.
That's me.
Your flaming marshmallow, you put it on your chocolate. Does it melt your chocolate? No, like it doesn't make that chocolate into a liquid, does it? No. But what does it do to the chocolate? Makes it ooey gooey, softens it. That's what's going to happen to their shoulders. So I'm now touching their shoulders and I'm basically hot lava burning their shoulders. I'm changing their shoulders. How are their toes? Why are your toes fine?
Not my shoulder.
Because it's not your shoulders. There's no lava touching his shoulders. So for contact metamorphism, it's when hot lava pushes its way up through the Earth's surface and touches the rocks around it. It will only change the rocks it's touching, unlike regional, which will change the whole area, whether it's touching the lava or not. So contact is just a small area. All right, moving on. Well, not time to do nothing, but that's okay. Rock name, you got it? Name of rock. Rock symbol, ignore for now. Yeah, ignore until chapter 6. Same thing I said the other day. This is not what it looks like. So there is no rock out there with a bunch of plus signs in it here like Hornsfeld. So do not look at that and say, oh, that's what the rock looks like. The last one is, oh yeah, and we got time for it. That's enough, I promise. The last one is the comment section. This tells you some extra stuff about the rock that might help you identify the rock. Or it tells you what the rock came from. In other words, it's called the parent rock. So not to weird you out, but you guys know you came from your parents, right? Okay, you understand. I'm not getting into details, not my class. Yep. So the parents are what the rock was before it got changed. If you look at the limestone box, for example, or not limestone, I'm sorry, marble. If you read the comments, it tells you it's a metamorphism of limestone or dolostone. So that means we gave limestone heat and or pressure. In other words, we gave parents heat and or pressure. Let's not get into details. And it made the new rock marble. So the parents are where it came from. Like I said, we have no homework. Those pages will be homework Tuesday. So they're the pages that came right before this. So I think it was 29 and 30 maybe, or 28 and 29 will be homework that I'm going to give you on Tuesday. And I'm thinking a test around Friday on all the rocks. All right. Enjoy your weekend, guys. Don't drive your parents crazy.